Hi, good morning, everyone. In this IXL video, we are going to be covering assignment D7, compare rational numbers. Now, before we officially get started, let's take a brief moment to refresh our memory on the term rational numbers. All right, right here, we have a nice little diagram of the real number system. Now, the real number system is our overarching umbrella term. Within that, we have all these different rings, all these different types of numbers. We're actually going to start in the middle and we're going to work our way out. So in the very middle, we have natural numbers. You will sometimes hear these called counting numbers because it's what you learned when you're a little kid, when you learned to count. 1, 2, 3, 4, etc. Then we get a little bit larger and we get to whole numbers. Whole numbers are all those natural numbers plus 0. So whole numbers are 0 and then 1, 2, 3, 4, 5, etc. We get a little bigger and that's where we get integers. This is what you're most familiar with seeing in pre-algebra, our integers. That is all of our negatives and positives. So all of our natural numbers plus their opposites, okay? Then we get a little bit bigger, and those are our rational numbers. Now, our rational numbers include everything else that's on the inside. So integers are a rational number. But rational numbers also include our fractions. So if you can write a number as a fraction, it's a rational number. It also includes some decimals because as you guys learned back in elementary school, you can convert a fraction to a decimal and vice versa. The one trick is with decimals, they have to be able to be rewritten as a fraction, which means either the decimal terminates, so that means it stops. That would be like this number right here, -8 7/10. Or 9 3/10. That's a terminating, a stopping decimal. Or a repeating decimal. If we come down here at the bottom and we look at the fraction -1/3, if I convert that to a decimal, it is 0 3/10 repeating. So 0 and 3, 3, 3, 3, 3, 3, 3, 3. So those are the two types of decimals that are included in the rational number ring, okay? And then irrational numbers, we're gonna learn about in a little bit. So that's kind of down here in the corner, but for right now, we'll just stick with rationals. So let's hop on back to that IXL video, not IXL video, that IXL assignment, and let's compare our rational numbers. All right, we wanna know which sign makes a statement true. So we have the fraction -3/6 and -1/2. I need to know if -3/6 is greater than, less than, or equal to 1/2. When we compare fractions, we need to ensure that our denominators, so that bottom number, is the same. If we don't do that, we're not comparing equal things. That would be like if we were trying to compare something that was in inches and in feet. That's not the same measurement, and so it's not going to be an equal comparison. If something is 1 inch, that's very different than if it's 1 foot. So same with fractions. Before we can compare these, we need to ensure they have the same denominator, okay? I'm going to go ahead and rewrite my fractions off to the side here so we can have room to work. There are two different ways that you can go about having like denominators. Either one, you can see if you can reduce a fraction, so make it smaller. Or if you can't do that, you can try to make you need to make one of the other fractions larger by finding that least common denominator. Okay? In this example, I can reduce one of my fractions, so we're going to do that. Because I notice that I have the fraction -3/6. Both 3 and 6 are divisible by 3. So I am going to reduce that fraction by dividing both the numerator and denominator by 3. All right, -3 divided by 3 is -1. 6 divided by 3 is 2. Now I have like denominators. They both have a denominator of 2, which means I can easily and accurately compare them. Well, this one's kind of a no-brainer. They're the same number, which means these two fractions are equivalent. They are equal. Yay, perfect. All right, let's try this one. Okay, we're going to rewrite our fractions here. We're comparing the fraction -2/5 to -9/10. All right, the first thing my brain goes to is I'm like, ooh, I can do just like before. I have a 10. If I divide 10 by 2, I'm going to get 5. And that's true. But what happens if I divide 9 by 2? Yeah, I'm going to get a decimal. I'm not going to get an integer, which I guess you technically could do that and still compare these, but that's not really best math practice because we either need to have a fraction or a decimal, not a combo. That means I'm going to find the least common denominator, and I'm going to multiply one of my fractions. I'm going to increase one of my fractions so that way they have the same denominator. All right, we have a 5 and a 10. Well, if I think about my multiples of 5, 5, 10, 15, 20. We got 10 in there. 10 is my least common denominator. 5 times 2 is 10, which means I'm going to multiply the numerator and the denominator because we have to convert this entire fraction by 2. -2 times 2 is -4. 5 times 2 is 10. Now I have equal denominators, which means I can compare my fractions. Yay! All right, we got one more little trick though. Our numbers are negative, which means we need to be careful as to what number is really bigger. What do you think? Is -4/10 greater than or less than -9/10? It, in fact, is greater than, because remember, with our negative numbers, the closer we are to 0, the greater the value is. So if I kind of do a little sketch of that on the number line, right here we'd have -4/10. And down here we'd have -9/10. -4/10, because negatives are backwards like that, is greater than -9/10. Right, excellent. Let's try a couple more here. Let's jump up a level. All right, here we go. So we want to once again know which sign makes the statement true. All right, we have 17/20, and we're comparing that to 1/2. All right, I need to find that least common denominator so I can compare my fractions. Well, if I think of my multiples of 2, I know that 2 is eventually going to get 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 20 is our least common denominator. What do we need to multiply 2 by for it to equal 20? Yeah, 10. All right, let's multiply. Ooh, that's a bad multiplication sign. Both numerator and denominator by 10. 1 times 10 is 10. 2 times 10 is 20. Let's bring our other fraction down, which we did not need to change at all. Love it when that happens. All right, these numbers are positive, which means I don't have to do that second guess, or I don't have to really triple check my work, because is 17 20ths greater than 10 20ths? Yep, 17 is greater than 10, which means we have our answer. All right, we are gonna do one more together here. All right, we have mixed numbers, okay? When you have a mixed number, you sometimes might be able to just look at it and know the answer, but that's not always the case. And because you lose SMART score points if you get a question wrong, I encourage you guys not to take that risk and to go ahead and work out the problem, because with those fractions, you never know. All right. We have 2 3/4. Yikes, that's a bad 3. And we're comparing that to 6 1/2. Just like before, I need my fractions to have like denominators. There's 2 different ways you could do this problem. One way is you could convert them into improper fractions. Another way is you can keep them as mixed numbers. I always like to try and see if I can keep it as a mixed number first, because that's less work, okay? All right, if we look at the fraction part of our mixed number, we have 3/4 and 1/2. What would be the least common denominator? 4. All right, and if I look right here, I can't reduce that fraction at all, because the only common multiple between 3 and 4 is 1. So that means I can't simplify, I can't reduce, but I can manipulate, I can multiply to make this 1/2 have a denominator of 4. We're going to multiply. Oops, I forgot to change my color. I'm making lots of mistakes this morning, guys. At least they're silly ones and I'm catching them, right? We all make mistakes. Okay, we'll multiply the numerator and denominator by 2. Now we don't need to multiply our whole number, because it's not like we're creating a new fraction. We're creating an equivalent, so an equal one. It would kind of be like, right now I have my dress shirt on. I could put a jacket on top of it. So I've added an extra layer of clothing, but it's not like but it's not like I really changed anything. I just added to it, added more clothing. Hopefully that kind of translates. All right, 1 times 2 is 2. 2 times 2 is 4, which means we are comparing 2 3/4 to 6 2/4. 2 3/4 is clearly smaller, so it is less than 6 2/4. If you guys have difficulty with your symbols, I'll be completely transparent. When I look at the symbols, if I just see 2 inequality symbols, I don't necessarily just know what they are. I have to put numbers around them. Like if I just were to randomly see this symbol, I pick 2 random numbers. I usually do 1 and 2, and I put them around. Once I do that, I do this all in my head, I'm like, oh, 1 is less than 2. That's my less than symbol. Okay, so if that's the part that's tripping you up, try it out with each symbol in there on your paper. Or if you're doing this on your phone and you can write on the IXL, do it on IXL like that and see which one works. All right, let's make sure it's correct. Oh, I forgot to actually click the button. Good thing IXL warned me. That was nice. All right, guys. Ooh, I lied. We're going to do one more because we have not had one like this. So there you go. You guys are getting a bonus problem. Okay. For realsies this time, our last problem. We are comparing 1/2 and 4/5. All right, what's our common denominator here? In all of our other problems, we only had to change one of the fractions. But can I multiply 2 by anything to make it a 5? Yeah, no. Can I reduce my 4/5? No, the only multiple, or the only factor that 4 and 5 have in common is 1. So that means I'm going to need to change both fractions so they can have a common denominator. All right, one way that you guys can do this is we need to find our least common denominator. If you're able to do it in your head because you got those multiplication facts memorized, excellent. But if you don't, you can write out your multiples. So we have 2, 4, 6, 8, 10, 12. I'm going to stop there for now and we'll do my 5s. And if I don't find anything that matches, I'll keep going. So my 5s, we have 5, 10, 15, 20. What do we have that matches? 10, which means 10 is our least common denominator. All right, if we look at our first fraction here, 1/2, 2 times what is 10? 5, which means we'll multiply this by 5. 1 times 5 is 5, 2 times 5 is 10. For our second fraction, we need our denominator to be 10. So 5 times what is 10? 2. 4 times 2 is 8. 5 times 2 is 10. Now they have like denominators and we can very easily compare them. We have 5/10 compared to 8/10. Well, 5 is less than 8, which means 5/10 is less than 8/10. I keep doing that. I keep forgetting today to click the actual button. All right, perfect. All right, guys, if you have any questions, please make sure that you reach out to your teacher and or go to a help session and we will be more than happy to assist you. Bye.